Hello viewers, in today's class we are going to discuss one important problem from three-dimensional geometry, and that is related to intersection of planes, right? So here in this lecture we are going to solve one important problem from intersection of planes, right? So here goes the problem. Find the equation of a plane which contains the line of intersection of the planes x plus 2y plus 3z minus 4 is equal to 0 and 2x plus y minus z plus 5 is equal to 0, and which is perpendicular to some other plane whose equation is 5x plus 3y minus 6z plus 8 is equal to 0, right? So here we have to find the equation of a plane which passes through the intersection of these two planes, right? And that plane is also perpendicular to this plane, right? So let us quickly revise the concept of intersection of planes. Suppose we have two planes, right? Suppose this is the first plane, and let us take the second plane like this, right? And see if we have a plane which passes through the intersection of these two planes, right? So suppose let us take this plane as x plus 2y plus 3z minus 4 is equal to 0, and let us take this plane as 2x plus y minus z plus 5 is equal to 0, right? So we are given two planes P1 and say P2, right? And these two planes intersect at a line which is given like this, right? So this dotted line is the line of intersection, right? This is the line of intersection of these two planes P1 and P2, right? So always remember, whenever two planes intersect, they intersect in a line, right? But when two lines intersect, these two lines intersect at a point, right? So two planes intersect in a line and two lines intersect at a point, right? Okay. So now here we have to find the equation of a plane which passes through the line of intersection of these two planes, right? So there may be an infinite number of planes which can pass through the line of intersection of these two planes P1 and P2, right? So let us take the plane like this. Suppose this is our plane which is required here, and this plane we can denote this plane by say P, right? So P is the plane which passes through the line of intersection of these two planes P1 and P2, and we have to find the equation of this plane P. So now suppose we are given a plane P1 like this and a plane P2 like this, right? And we have to find the equation of a third plane which passes through the line of intersection of these two planes, and that plane is P, right? So the equation of this plane P is equal to P1 plus lambda times P2 is equal to 0, right? So this is the key concept in the intersection of planes, right? So the equation of any plane P which passes through the line of intersection of two given planes P1 and P2, then the equation of this plane P is given by this equation, that is P1 plus lambda P2 is equal to 0, right? And in this problem we are given the equation of this plane P1 as x plus 2y plus 3z minus 4 is equal to 0, and P2 is given as 2x plus y minus z plus 5 is equal to 0, right? So now what we will do, to find out the equation of this plane P, we'll substitute P1 as this value and P2 as this value, right? So we'll take the left hand side of this equation and the left hand side of this equation, and we'll put it in this equation. So now this equation becomes, for P1 we can write x plus 2y plus 3z minus 4, and then we have lambda times P2, and for P2 we can write 2x plus y minus z plus 5 is equal to 0, right? And here this lambda is some scalar, or it is some real number which can be determined by using some other condition, right? And the other condition is given over here, right? Because this plane P is perpendicular to this third plane, that is 5x plus 3y minus 6z plus 8 is equal to 0, right? So our next step is to utilize this condition, but before utilizing this condition, let us first rewrite this equation like this. So now here we can write this equation as 1 plus 2 lambda x plus here we can write 2 plus lambda times y, and then we can write 3 minus lambda z plus minus 4 plus 5 lambda is equal to 0, right? So what we have done over here, we have collected the coefficients of x, y and z and the constant term, right? So now we have expressed the equation of this plane P in the form that is ax plus by plus cz plus d is equal to 0, right? So any equation of this type always represents a plane, right? And a, b and c are the direction ratios of the normal vector to this plane P, right? So see here, if we compare this equation with this one, then A is 1 plus 2 lambda, B is 2 plus lambda, and C is 3 minus lambda, and D is equal to minus 4 plus 5 lambda, right? So A, B, C are the direction ratios of this plane P, right? And the normal vector to this plane P, it looks like this, right? So this is the normal vector to this plane P. So now our next aim is to find out the value of this scalar lambda, right? So in order to find out the value of lambda, we'll now utilize this condition, that is this plane P is perpendicular to this plane, right? That is 5x plus 3y minus 6z plus 8 is equal to 0, right? So let us draw a rough diagram to represent this plane, right? So now let us draw this plane. Suppose we draw this plane like this. Here we have this plane and we can draw it like this, right? And if we denote this plane by say P4, right? So this is P4, and now this plane P is perpendicular to this plane P4, right? So we know that if two planes are perpendicular, then their normals are also perpendicular, right? So the normal vector to this plane P is given by vector n, and the normal vector to this plane P4, which is given by this equation, is like this, right? So this is the normal vector, say n4, right? So n4 is now perpendicular to n, right? So n is the normal vector to this plane P, and n4 vector is the normal vector to this plane P4. So when two planes are perpendicular, their normals are also perpendicular. So vector n is perpendicular to the vector n4, right? And we have here seen that the direction ratios of the normal vector n are given by 1 plus 2 lambda, 2 plus lambda, and 3 minus lambda. And the direction ratios of this normal vector, that is n4, are given by the coefficients of x, y, and z, right? So the direction ratios of the vector n4 are 5, 3, and minus 6, right? And the direction ratios of this normal vector n are 1 plus 2 lambda, 2 plus lambda, and here we have 3 minus lambda, right? So now from vector algebra we know that when two vectors are perpendicular, then the product of the direction ratios and then we take the sum is equal to 0, right? So here we have the condition, that is a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? Where a1 b1 c1 are the direction ratios of the first vector and a2 b2 c2 are the direction ratios of the second vector. So here a1 b1 c1 are given by 1 plus 2 lambda, 2 plus lambda, and 3 minus lambda, and a2 b2 c2 are given by 5, 3, and minus 6, right? So now we can write this equation as 1 plus 2 lambda, 1 plus 2 lambda times 5, then we have b1 b2, so 2 plus lambda times 3, and then we have 3 minus lambda times minus 6, right? And that is equal to 0. So now we have an equation in terms of lambda, so we can simplify it. So we have 5 plus 10 lambda, then we have 6 plus 3 lambda, then we have here minus 18 plus 6 lambda is equal to 0, right? So here we have 10 plus 3 13, 13 plus 6 is 19 lambda, then we have 6 plus 5 11, and 11 minus 18 is equal to minus 7, right? So from here we have 19 lambda is equal to 7, so lambda is equal to 7 over 19, right? So this is how we find the value of this scalar lambda, which is equal to 7 over 19. So once we have obtained the value of lambda, we can now substitute this value of lambda in this equation to get the equation of the plane P, right? So now we can write x plus 2y plus 3z minus 4, and here we have for lambda, that is 7 over 19, and we have 2x plus y minus z plus 5 is equal to 0, right? Now we can multiply this equation by 19 to get rid of this 19. So we have here 19x plus 2y plus 3z minus 4, and here we have 7 times 2x plus y minus z plus 5 is equal to 0. We can simplify it. So we have 19x plus 38y plus 57z minus 76, and here we have 7 2s are 14x plus 7y minus 7z plus 35 is equal to 0, right? So now we can combine the like terms here. So 19x plus 14x is 33x, and 38y plus 7y is 45y, and then 57z minus 7z is 50z, and then we have minus 76 plus 35 is equal to minus 31, right? So this is 41, right? So here we have minus 41, right? So the equation of this plane P is given by this equation, which is 33x plus 45y plus 50z minus 41 is equal to 0, right? So viewers, the equation of the plane which passes through the intersection of these two planes and perpendicular to this plane is given by this equation, right? So this is how we can solve this problem related to intersection of planes.